Hi friends, today's topic is static electricity. Discovery of static electricity. If we look back to the history of static electricity, in 600 BC, a Greek mathematician Thales observed that paper is attracted by an amber when it is rubbed with animal fur. Later, in 16,000 AD, an English physicist William Gilbert showed that not only amber and animal fur, there are many substances which gains force of attraction after rubbing two different materials. Like, if you comb your dry hair with a plastic comb, you will see that it will attract the small pieces of paper. And in this picture, the foam is attracted by the cat's fur. Let's do an experiment. First, we will take an ebonite rod and a piece of silk cloth. Now the ebonite rod is rubbed with the silk cloth. Now, if we bring the ebonite rod near the small pieces of paper, we will see that the papers will get attracted by the ebonite rod. All these phenomena are directly related to the static electricity. When we rub two different materials, the materials will get electrically charged. Now some question arises from this experiment. Number 1. How the materials become electrically charged? Number 2. Which will be positive and which will be negative? Number 3. In spite of being neutral, why the papers are attracted by the charged material? Before we know all the answers of 3 questions, we must know about the electron affinity. Electron affinity is the ability of a material to hold the electron. Different materials have different ability to hold the electron. Here in this series, some materials are arranged with their respective electron affinity. This series is called the Electrostatic series. The materials which have higher position in this series are more prone to lose electron and turns positive. The materials which are lower in this series is more prone to capture electron and turns negative. So, if any two different materials in this series are rubbed with each other, the material which is higher in this series will get positive and the lower will get negative. Like if we rub glass and silk, the glass will get positive as it is in number 4 and the silk will get negative as it is in number 8. Now let's zoom in our experiment and see how they are get electrically charged. At first the ebonite rod is taken and silk cloth is taken. Then they are rubbed with each other. Now, as the silk is higher in the electrostatic series, the silk has more prone to lose electron than the ebonite, and the ebonite has more ability to capture the electrons. So, some electrons in the silk cloth will get transferred to the ebonite. So there will be a deficiency of electron in the silk cloth, and there will be an excess of electron in the ebonite rod. So the silk cloth will get positive and the ebonite rod will get negative, and they will have same amount of charge. So we have answered our first 2 questions. We will go for the third question. In spite of being neutral, why the papers are attracted by the charged material? We know the paper is mostly made of carbon atoms. So for simplicity we will take the carbon atom. Now, if we bring the negatively charged ebonite rod closer to the carbon atom, what will happen? The electrons will get repelled by the negatively charged ebonite rod, and there will be a charge imbalance in the carbon atom. So, the side which is closer to the ebonite rod will have deficiency of electrons, so it will get positively charged, and the side which is away from the ebonite rod will be rich in electron and will turn negative, and the paper will get attracted. This phenomenon is called electrostatic induction. In insulator, it creates the polarization. At last we will discuss about concept of electrostatic shielding. Now assume a rat is being hit by a lightning strike. Now what will happen? The cat will be fried in no time. Now we will do the same experiment, but now we will put the rat in a metal cage. Mind it, the metal cage, not ordinary plastic cage. Now if lightning strikes to the system, what will happen? We will see the rat will run away if the cage is removed. This phenomenon is called the electrostatic shielding or electrostatic screening. It was first discovered by great scientist Michael Faraday. So how this miracle happened? Before we know the answer, we must know a theorem. For a closed conductor, electric field inside is zero. More about electric field will be covered in the upcoming videos. So as electric field inside is zero, no charge can be found inside the cage and there will be no electrostatic induction also. So the charge will stay outside and the rat will stay safe. So enough for today. If you like this video, you can support me by giving a like, share with friends and subscribe to my channel. Don't forget to add the bell icon for the latest notifications. Thank you.